What is going on, guys? Welcome to another video of the C programming tutorial. Today we will cover variables and data types. Variable is a way to temporarily store information that can be used later. Variables are stored in the memory, in RAM memory, and the information that is stored on variables is not persisted once the program finishes. So whenever we terminate our application, the data is gone, or at least it's marked to be deleted. If we need to persist any type of information, we will need to manually store it on the hard drive, on your hard drive. Otherwise, it will be lost. And constants is one type of variables that do not change their value during program execution. We will see more in detail later how we can use variables and how to create them. So some conventions about the naming of the variables and some rules that we need to follow. So all names must begin with a letter or an underscore. Okay, you cannot start it with a digit, numeric digit, and can be followed by any combination of letters, digits, or underscores. Okay, so these are the characters that are allowed and the rules for the first letter that we need to follow. So variable names cannot contain spaces. So whenever we need to have a variable name that has more than one word on it, usually what we did is that we started the next word with uppercase. Okay, like we will see on the fourth point. So C-reserved words cannot be used as variable names. For instance, you cannot use int as a name of a variable because it's a data type. We will see in a few slides further. And like I was mentioning, it's a good practice to start variable names with lowercase, and all subsequent words will start with an uppercase. And we have some examples. So age is just one word, so we type it with everything in lowercase. First name, there are two words, so first starts with lowercase and then name starts with uppercase, and same thing for number of wheels. In this case we have three words, so whenever we start a new word, except for the first one, we use uppercase. So this is the rules, or some are rules, some are mandatories. For instance, like the first point, others are just good practices that we need to follow. So whenever we talk about variables, we also need to talk about data types. And data types is a way to mention what type of data will be stored on a particular variable. For instance, it's a way for me to say I want to store numbers, or I want to store numbers with decimal places, or letters, etc. We will see what are the most common data types used in C in the next slides. So according to this data type, the data type will also help to identify what is the computer to identify what is the amount of memory space that is required to store these variables on the memory. Okay, and some basic examples of data types we'll see more in detail in the next slides, but are int, float, double, and char. Okay, so the first data type that we will look on is the int, and this int is used to contain integral values only, so values with that do not contain decimal places, and it supports positive, negative, and zero values. It's assigned, in other words. So usually it takes 4 bytes of memory, but bear in mind that in this slide and on the next ones, the amount of space that it occupies on the memory, as well as these ranges of what's the minimum and maximum value that we can store on them, they depend on the computer architecture, on your current architecture. So they are not constant and may vary according to the architecture that you are using. So this is an int, so it's very common. There are some variations of the int. We will not use them at all, I believe, during the course. At least I cannot think in a scenario where I want to use them, but bear in mind that there are some variations, like you can use unsigned int, and in this case everything will be positive, and you can cover a bigger range of positive numbers because you don't need to use the memory for the negative values. and some other variations that we will not cover. We will keep with the basic data types, not the variations. Okay, so the next data type is used to contain numbers that have decimal places. So int is whenever you don't need decimal places. Float we use for floating point in numbers. In other words, whenever we need to have numbers with decimal places. Similar to the int, it supports positive, negative, and 0, and it also takes 4 bytes of memory. And the fourth point, you can see the range that you can use in a typical architecture. But again, this may vary according to your architecture, of your computer architecture. So next one is a double. It's very similar to the float, but we can have a bigger range of numbers. It's more precise because we can have many more decimal places. So whenever you have to use a number that you need it to be very precise in terms of the decimal places, and it's a very big number, it's usually a good idea to use double. Okay, and the char data type is used to represent a single character. Okay, this is not a word. You cannot type a word on it. It's just one letter. We will see later how we can store words and sentences on a variable. But for now, bear in mind that char is just one letter, a single letter, a single digit, or a single symbol. It's just one character. And there are some characters, some special characters that if you see on the first column that says sequence, even though you have apparently two characters, they are interpreted by C as just one character, and these are called escape characters. There are more than these ones, but these ones are the most common ones. So whenever you type \B, that means you are doing a backspace. The computer will interpret it as a backspace. \N, it will be interpreted as a new line, and \T will be interpreted as an horizontal tab. In this case, it will be interpreted as the same as you press tab on your keyboard. And another data type that we have, or not entirely have, is the Boolean. And when I say not entirely have, is because C natively doesn't contain the Boolean data type. So we typically use the int to represent Boolean, and the Boolean is something where it's a data type where we have only two possible values, true or false. So if since we are using an integer to represent it, the way that it's used on C is that 0 represents false and 1 represents true. Okay, there are some ways around it. There is some library that you can use on your program, some library that you can import to your project, and it will allow you to instantiate a Boolean itself, and then instead of having to set value as 0 or 1, you can actually type true or false, which is more clear when we are reading the code. But during this course, we will try to go as much as possible with out of box, so what C gives us. Some things we cannot avoid, but for this case, for Boolean case, we will use the int to cover the Booleans. So how can we declare variables? Okay, so we can declare variables in some different ways. So if we want to declare just one variable, so a single declaration, the syntax is that we have to tell the first word is what is the data type that we will use, followed by a space, then followed by the variable name, what's the name that we want to name our variable, and followed by the semicolon. So some example of that is like this line, int x and semicolon. Okay, we can also declare variables, more than one variable that are of the same type. This is only possible if they have the same data type. So in this case, we would type the data type and the variable name for the first variable, then a comma, then the name of the second variable, the name of the comma, the name of the third one, etc., and followed by a semicolon. It's missing on the slide, but you need to end with a semicolon. So an example of that would be the last bullet point that we have, which is int space x comma y comma z. The spaces between the comma and the name of the variables are not required, okay, but I think it makes it more readable to have the spaces on. So another more on the declaration of and initializing. Okay, so declaring is like we saw previously, is just we are declaring but we are not assigning any value to the variables. But if we want to, we can write on the declaration, we can also instantiate or initialize the value of the variable, and this doesn't prevent us to change the value during the program execution. It's just like a default value that we want to have until we change it. Okay, so if we want to do this, it's very simple. We just declare the variable like we were doing before, so DataTypes space and the variable name, and then we put an equal sign and the variable value, so the value that we want to assign to the variable. So if you see on the next bullet point, what we have is int x equals 1. So in this case, whenever I reference to x, it will have the value 1. And similarly to the declaration, we can also declare and initialize multiple variables at the same time, as long as they are of the same data type. And you guessed it, is the syntax is data type and then space followed by the variable name equals the variable value separated by comma, and you'll do the same for the next variable. So variable to name equals the variable to value, and we can have more, as many as we wish to. So this would be something like the last bullet point, where we have a hint, then x is the name of the variable 1 equals to 1, so it's the value of the variable 1, then a comma, and we have y, which is the variable name for the second variable, and equals 2, and whenever we don't want to declare and initialize anything else, we place a semicolon to end the instruction. Okay, so let's see some samples now. So right now I am on Visual Studio. I have an empty file, a CPP file, and a new project that I've created. So let's start by creating our basic structure that we saw last class. So let's include the library to print into the screen. So stdio, and this will be pretty much common to every single project that we do. And let's initiate our main function. So int main, and then we will put brackets here, and finally we will return 0. Okay, so that's the basic structure. In this case, we will not print any message to the screen, so we will start declaring some variables. So let's try to create one variable for an integer. So let's type the data type, which is int, the name of the variable, let's call it x, and there we go, we have our int variable declared. Okay, now let's create another one, another int, so let's call it y, and in this case I want to initialize it also, so let's put equals to 2 and a semicolon at the end. Okay, so another thing that we can do is, for instance, let's also initialize variable x. Okay, let's make it 1. And we can do operations and store the result in some variable also. So we can do like int, we'll store the result, and it will be equals to x plus y. Okay, and in this case, in the variable named result, we would have the value 3 because the sum of 1 with 2 is 3. Okay, and if we want to prove it, we will print this value into the screen. However, this is a topic that we will cover in the next lesson, how to print data into the screen and read it. But anyways, let's get a bit ahead of ourselves and let's print the value that is here. Don't worry for now about the syntax. So let's print the value of result. And if we run this, we see the value 3, which is the sum of 1 plus 2. Okay, so let's close the window. Okay, so now let's create some floats. Okay, so let's create a float and let's call it A, where the value is like 1.5, and another float B, where the value is 4.2. Okay, and we can again do the same calculation. So let's call it let's create a variable to store the result. By the way, this is not needed. We will see more ways to cover this in future. So float, let's call it float result, float sum result, and let me put some emphasis on the way that we defined for the name. Okay, the naming convention. So float starts with lowercase because it's the first word, and every single other word starts with a capital. So equals the sum of A plus B, and we can also print it to the screen, so printf. And in this case, since it's a float, it's not an integer, we will not use %d, we will use %f, but we will cover this in the next videos. And we will use float sum result. And notice that Visual Studio is giving us some hints of what we can use. So we'll take care of that. Okay, so if we run this, the result is 35.7000, and this is because if you remember the first calculation, the result is 3, and for this sum over here we should have 5.7, and since we haven't placed any new line, sorry, let me put that back on screen, it's all in the same line. So 3, the number 3 that we see is the result of the first operation, and 5.7 is the result of the second one. So let's actually insert here a new line after printing this by using the escape character that we saw during the presentation. So this \n will introduce a new line for us. Okay, so let's close our application and run it again, and now we should see both results on different lines. So first result 3, second result is 5.7, which is actually correct. And some other, let's actually put also a new line here in case we type something in front. Any other operations that you can use is you can do this subtraction instead of addition, so we can do b minus a, for instance. This is also valid. And actually let's keep it as was, and we'll copy and do different. We can modify this one, minus b, instead of sum we'll do sub, which is the subtraction. And actually let's switch them because b is bigger than a. It was okay, we would have a negative value, but it's let's keep it positive. So now float, and let's call it float div result, and let's actually type it together. So we can do like b divided by a, this is a division, and you can also do float mult result, and you can do a times b. But these are the operations, the most common ones, and you can do them with any data type. You can do them with integers, floats, and so on. Okay, so let's print the messages to the screen. So I'll copy and paste this 4 times, and now we'll switch the variable name just to have the results. Yep. So let's save and run our program. So if we run it, we have the 3, which is the sum of 1 with 2, and then these calculations here are printed also. So the a plus b is 5.7, b minus a is 2.7, b divided by a is 2.8, and a times b is 6.3. Okay. So Similarly, no more news about the other ones. They will be similar, so we can create doubles, like C equals 2.3, something like that. This is how we would declare and initialize a double. Okay, the syntax is similar for the other ones also, and we can use an int Boolean value. Let's not call it value actually. Boolean var. We can set it to 1, which in this case would be true, and into let's actually int true var true, and we can do int Boolean var false, which would be 0, and we will see what booleans are commonly used for in future. Let's give us some more space over here, and finally we will declare a char. So we will type char, and let's call it char f, and name of the variable is f. And the way that we initialize a char is by putting the single quote and the character. We can put it any type of character. Can G and put a number here. Numbers are also valid, or symbols are also valid. You can put like hashtag. Okay, so these are all valid ways of declaring variables. We will use variables throughout the course. Variables is a very useful resource for whenever we need to store a value and use it later for other purpose. So we will use them thoroughly throughout the course. So that's that. So that's it. Thank you for watching. I hope you liked the video, and if you have some question or any suggestion that you want to make on how we can improve these courses, and any doubt, feel free to leave a comment and I'll try to answer as soon as possible. And if you like the content and want to keep watching, don't forget to subscribe to be notified whenever there is a new video released. So thank you for watching. I see you in the next one.